I'm Xiang from Alibaba, so I work on Kubernetes and SAD. So previously I worked for CoreOS, and she's Wenjia from Google, and she also works on Kubernetes and SAD. Okay, so today we are going to talk about SAD, and this session is Q&A like sessions. So we have some prepared questions, and those questions are frequently asked questions. We will first go through some of these questions pretty quickly, and then we'll leave time for you guys to ask us questions. So actually, besides us, there are other familiar faces here. A few SAD maintainers are in the front line, so maybe they also can answer your questions. So ask us easy questions or hard questions or whatever. Okay, so here's the first question.
Yeah, so we're going to start with the easiest questions ever, but could be confusion. This is a website that's deprecated for official SAD documentation. So if you're taking pictures, don't take pictures of this one. Also, it says it's the latest. It's not the latest. We stopped maintaining that website. And our new website is right under the SAD REPL documentation. We constantly update that documentation. And I know Gyuho is working on a new documentation website. Any contribution or suggestions, comments are welcome. But before that one is up, please use this one for the most updated information. Now, we know that SD has been used under a lot of different projects. Among all of them, Kubernetes probably still the biggest one. And also it's KubeCon. I think it's only fair to mention why Kubernetes use SAD as the data store for the Kubernetes control plane. There were two major reasons. The first one is high availability. One of the most important reasons that people use Kubernetes is to embrace the high availability. Excuse me. And it only makes sense if the It only makes sense if the underneath data store is also high available as well. And SAD clustering is intended for high availability. So here we go. That fits the needs for Kubernetes. And then the second reason is that it's a watch feature that SAD implemented. We know that one of the core design concept of Kubernetes is level triggering and software reconciliation. To do that, Kubernetes use watch to constantly monitor the change for all the resources and use a control loop to drive the actual state of the resource to the desired state of the resource. And in that picture, how does Kubernetes do the watch? Use the SAD watch feature. SAD's watch feature implement the event-based interface that for asynchronously monitoring the change to the keys. So every time there is some change to a key, the watchers get notified, which is exactly what Kubernetes needs. And I show this diagram of the talk between API server in Kubernetes and etcd. So they have this watch stream established between them, and then API server in Kubernetes establish the watch in that string and get the watched event from that stream. There is a talk tomorrow afternoon, the last talk of KubeCon, talking about more details of watch in Kubernetes. You're welcome to join.
Okay, the next question, why does SAD prefer odd number of members? So people usually add more members to SAD cluster to increase its fault tolerance. So if you look at this table, you will see that if you have even number of nodes, the fault tolerance doesn't really increase. So that's why we always suggest people to prefer odd number of nodes. But if you want to run even number, that's also fine. For reasons like you want to scale up your read capability, you probably want to have even number, but that won't help with fault failure tolerance. So the next question, what are WAR files? You probably heard about like, okay, SAD have the concept of WAR files, and SAD needs to sync the WAR files down to the disk. So what are WAR files? So WAR file is, so from conceptually, it's just a file on disk, and inside the file, there's list of entries, and each entry is an action. And for example, site foo equals bar or set Kubernetes equals awesome. And for those entries in the WAR file, that's an internal etcd key value store will keep on executing them one by one to change the internal state of the key store. So from the client view, the client keep on sending the data, the request to the etcd server. It can send the request to different etcd servers in the cluster, but all the servers will send the request to one Raft cluster, and the Raft cluster will make sure that all the etcd server have one consistent or the same WAR file on disk. So if the client send one request to etcd server 1, it will go through Raft and add an entry in the WAR file. And similarly, if it's sent to the third machine, it will get onto the WAR file. And if it's sent to the second one, it will go through Raft again and append on the WAR file. So you will see that the WAR file will be the same on all the machines, and all the machines will execute the WAR file in the same sequence. So the state of all the etcd servers will be the same. That's how etcd makes sure that all the members in the cluster have the consistent state. So WAR file is very important.
For the people who joined later, there are some seats in the front. Please feel free to join. Now, I want to ask how many of you actually use etcd cluster across region? All right, good. No matter if you use that or not, there are some information for you in this topic. Does etcd work with cross-region deployment? The answer is big yes. Not only that etcd could do that, it also brings you fault tolerance improvement. So this is supposed to be like a representation of the Earth, and the 3 regions are the KubeCon collocations. Not that we have tested in these 3 different regions, but the cross-region deployment of etcd cluster does come with a price. The cost is the higher consensus latency. Since etcd relies on member quorum for consensus, so the latency that coming from the crossing the data center boundaries would be pronounced because at least the majority of the member have to reply to the consensus request. And additionally, since all the cluster data has to be replicated into all peers, so there will be bandwidth costs as well. And keep in mind that the default etcd configuration is only set for local deployment. So if you do the high latency deployment, then it's possible that you will have more frequent leader elections and you will have heartbeat timeout. It doesn't mean you cannot do that. It only means that you have to tune some of the parameters to adjust for your deployment. And we do have official documentation on how to help you how to do the tunings. And it's a big topic of how to upgrade and downgrade etcd if you're using, no matter if you're using etcd under Kubernetes or anything else. So we want to talk about this a little bit. Before you even start to upgrade or downgrade your etcd, please make sure you have backup. Etcd cuddle snapshot is the command line that you use to do the backup. It's very easy, but make sure you do that and make sure you check if the file that you backed up is valid, and also do periodically validate that you can restore your backup. And have that set, we're ready to talk about how to safely upgrade etcd. There's 2 important things that you need to keep in mind. One is you can only do rolling update, which means if you have a cluster of a couple of different members, then you have to upgrade the members one by one. And you can only do 1 minor version upgrade at this time, which means if you have a 3.1 cluster and you want to eventually upgrade it to 3.3, then you have to upgrade it to 3.2 first. You have to be, 1 year old before you get to 2 years old. All right, now let's take an example. If you have a cluster of 3 members, each member have their own member version, and then the entire cluster have a cluster version. The cluster version is decided by the lowest member version, which means in this case, let's see, we start with the cluster version of 3.2. And then you start to do the rolling update and update one of the members to 3.3. And the entire cluster is still 3.2 because the other 2 are still 3.2. So all the members can only support 3.2 features and data files. Then you update another one, still we have the lowest version of 3.2. Not until you successfully upgraded all the members to 3.3 that the cluster version would change to 3.3. And we do have very detailed documentation on how do you upgrade your SED from 3.1 to 3.2 to 3.3 to 3.4. And it not only document the detailed steps, but only all the things you need to keep in mind because the changes made between different versions. So make sure you look into that. And for downgrade, we only support downgrade with downtime at this moment, which means you have to stop everything, bring up your downgrade SCD with the lower version, and then start everything again. And the downgrade with no downtime is on the way. And it will be out in V3.4, which is going to be next year. And you can refer to issue 9306 for the detail of this effort. Any contributions or suggestions are welcome.
Okay, the next question is, what is the database file? You probably heard that, okay, besides the WAR file, SCD also has a database file, right? So I just mentioned that in the WAR file, it stores all the actions SCD will take. And if you think that, okay, if I run SCD cluster for 12 hours, and if I restart the SCD node, does it need to replay all the logs for the 24 hours? Right? If it needs, then it will take a long time. Also, when a new member joins the cluster, it needs to get all the entries from existing members and reapply them. That will also take a long time, right? So that's why we introduced the database file. So the database file contains a checkpoint. So periodically, SCD checkpoint is in memory state onto disk. So when a member restarts, it only needs to reply the entries from that checkpoint. Also, when a new member joins the cluster, it first will get the database file which contains the checkpoint, and then get all the entries after the checkpoint, and then start to reapply all the entries after the checkpoint. That will reduce the cost of restart and a new member to join the cluster. That's why we have the database file. And now we use BoldDB, a B+tree implementation in Go, to save the checkpoint file. So that's why there's a DB file. If you want to interact with it, you can use the BoldDB command line to see what is actually inside there. So the next commonly asked question is, why does SCD have a dataset limit? So as I just mentioned, when a new member joins the cluster, it needs to get the entire database file, right? And if the database file is very large, it will take a long time to downloading the file and to open the file. And in SCD, what we really care is about the mean time to recover. So we want to say that, okay, if your SCD cluster lost a member and you add a new fresh member back to the cluster, we want the mean time to recover time to be lower than 3 minutes. So that's why we set a data size limit. We set it to 2 gigabytes, which means that on typical AWS small deployment, 3 minutes is good enough. 3 minutes is good enough for you to get the 2 gigabyte snapshot from any member still in the cluster. And if you want to increase the database size, data size limit, probably you need to have a higher I/O throughput for your deployment and then test it out. If it's still under 3 minutes, you are good to go. And another limit of the data size is your memory. So SCD data is actually mapped, which means that we expect all your data sitting inside your memory. So make sure that your memory is larger than the database file or larger than the total data you put into SAD, so that SAD can still have fast access for reads. And the next question is, why does SAD require compaction? So in SAD 3, we start to keep all versions of keys, which means that if you change the value of a key, your old value of that key will still be there. You can still access them by pointing to a previous version. Say right now the version is 3, you add a key, you change the key, the version will be 4. If you still tell SAD, okay, I want to get the version 3 of that key, you will still see the old version. This feature is designed for configuration rollback and a reliable watch. So for reliable watch, it's similar to how Kafka off that works. So you can still walking through the history from old version to the new version. But when we start to keep all the versions, if we don't do compaction, you can think that the database size will keep on growing and growing. It never shrink, right? So compaction is to remove the old version of keys. So when you know that, okay, those keys are not necessary anymore, you can compact them, and then SAD will start to delete them in background. It won't. The delete will take some time, but it won't block any writes in the future. It's all done in backend. Oh, sorry. Say.
Is there an API or another way for user of EPC to know how many unused keys are in the system?
Right now, I think we measure the total number of keys, and we measure the total number of keys in the BoDB backend. So if you do the math, you will know that how many keys are not it's not unused. We don't know whether you are using it or not, but it's old keys. So you can do the math to calculate how many old keys are there, right? But those old keys may still be useful, right? Yeah. Maybe we'll add a better API just to tell you that, okay, how many old version of keys. That's a good thing to add. Any other questions around this? Okay. So another question is why SAD is sensitive to I/O latencies. So SAD is sensitive to the network I/O latency because we use Raft as the underlying consensus algorithm, and Raft is a leader-based system. So the leader needs to keep on sending heartbeats to the follower, and so normally the follower will receive it within the timeout, and the follower will stay in the follower stage. However, if the I/O latency is long and the follower cannot receive the heartbeat in time, it will try to become a candidate, which can disrupt the cluster stage. And that's why SAD is sensitive to I/O latency. So in 3.4, we are adding a feature called Provote to mitigate this problem. So the candidate node will not disrupt the leader, the cluster, right? But still, it will become candidate. So we suggest you to tune the I/O, the timeout, heartbeat timeout and the election timeout to make sure that it works well for your deployment. For normal deployment within one region, you don't need to do anything, but for the cross-region deployments, you probably need to want to turn your timeout.
Is there any kind of automatic tuning of the timeout based on the cluster?
No, we don't have it now, but we may want to provide a tool to help you. Basically, it will depend on your round trip time between the two nodes. We can add a tool to help you to do that. So we suggest to have the election timeout 10 times to your round trip time, and heartbeat time around the round trip time of your latency. That's our suggested value. But we don't have a tool to automatically calculate that for you, but we can help you to do that.
So basically your suggestion is at cluster setup time, you do some RTT measurement, and based on that,
yes,
you configure the...
Yes.
Okay.
Is that leader election latency exposed for something I can go capture and measure over time?
I don't remember. I don't think there's a matrix for that, but it's configurable. But I don't think it's exposed. But when you are reaching the timeout, SAD will print out a log saying that, okay, it's near the timeout. There's a warning in the log. But we can expose it as a matrix. But for the I/O latency, we do expose the matrix. So you know the current I/O latency between your two nodes, but we don't expose the your configured election timeout. Okay.
The performance is always a very important topic as more and more people are using it in production. We not only want it to work, but also it better work efficiently. So there are a couple of important numbers to remind you. The two performance factors are latency and throughput, like anything else. And then there are two physical constraints for SSD performance, networking I/O and disk I/O. Make sure you understand the scenario in your environment. And then we do have a benchmark tool in SSD repo. We do suggest you to, and along with the benchmark tool, there are current benchmark results posted on that documentation as well. It was based on a certain set of configuration. Do make sure you cross-reference with whatever the hardware configuration that you have, and refer to the result and reason the relationship between them and make judgment on what if the performance meets your requirement. And we do suggest you, like every time you change your environment or change your hardware configuration, do the benchmark performance again, make sure it's right for you. And this is supposed to be the last slide, but then we do have two extra slides. I decided that it's important enough to mention before we get into the real Q&A session. This is how you could help with the SSD communities. I did this little survey before we start the talk. Apparently, there are a couple of people already contributing to SSD, and everybody else is planning to contribute to SSD. So we have the contact here. You can email to SSD Dev Google Groups, and we had a community meeting before, bi-weekly, and we are planning to reassume the community meeting as we see a lot of people are more and more interested. So it will start, since it's holiday season, will start right after the holiday season, January 8th at 11 o'clock in the morning Pacific time. And it will be monthly, and then you can go to that link. It will have, like we usually have agenda. You can put your agenda in there if there is anything specific you want to discuss. And then issue and PR could be created in SSD repo. Don't think you can only contribute that if you're writing codes, right? If you post your use case, you post questions, and we know what's going on outside there. Everybody using SSD different ways, everybody using Kubernetes different ways. So please post stuff there and contribute. And with that, there are some areas that you could contribute right away. Like we do need a lot of tests. And well, if we don't know your use case, we don't know what other tests we can do. And then, as I mentioned, there is a new documentation website in progress, and you can take a look at that, and you can contact Yuho for if you want to contribute, if you have comments. And then we do want to have more documentation on SSD metrics. We know people might have questions about which metrics you want to see, which metrics you want to use, and which metrics you need to monitor and alert. If you can contribute your experience to help others, that'd be great. If you can pose questions, so we know what we need to do better. And then downgrade support is in that issue. And then non-voting member is in that issue. Those are all good areas that you can start.
So now we are open to questions. So let me know. Okay, maybe this.
Yeah, I'll hand out the microphone.
Sure. So in the SSD documentation, there's it said that the SSDs are recommended or required. Mm-hmm. So can you kind of elaborate why, and like what's the issue with like?
Yes. So I just mentioned that we have no, I have a microphone. So we have the database file right now. It's mmampt. It's a B plus tree, and for B plus tree, it requires random writes when you merge the in-memory tree back to the on-disk tree, and that will cause a lot of random writes I/O, and SSD is better for that. So if we want to solve this problem, we may add some other like LSM-based backend which handles like change the random write pattern to a sequential write pattern. I'm working on a new backend for that, but right now we still require the SSD. But SSD is like popular. Everybody are using SSD, so yeah, that's why we choose SSD. Oh, yeah.
I have a question about like cross-region use case. Is there any way to rank rank the members that the client is talking to by preference? Because we found that like if you have members in a bunch of regions and you happen to establish a watch cross-region, that it's much more expensive than establishing it locally. But we still want the clients to be aware of all regions, because like if the local region member is down, we still want to we're okay with a cross-region watch, but we'd rather avoid it by default.
So in SAD2, the earlier version of SAD, I think Hitoshi added a feature to SAD client to have priorities on different members. So we probably also want to do this for the SAD3. I'm not sure like if we have plans for that, because Guho is just rewrite the gRPC backend, the gRPC balancer for SAD client. Probably after this rewrite, we can add the feature you would like to see, the setting the priorities for the deployment. But also, we can automatically measure the the network latency between the nodes, and then try to set the priority automatically if you care about the latency. Yeah, maybe create an issue in SAD repo so we can track that and we can help you.
Is there any work being done towards adding a Byzantine fault-tolerant consensus mechanism in place of Raft or in addition?
So right now we don't have the plan, but if you have a use case, you can send it to SAD repo so we can understand your use case and understand why you want to do that. Because right now we assume that all the SAD clusters are like managed by one party, and yeah.
Thank you. We have a use case with a regular etcd supporting Kubernetes. And sometimes when we take one of the members for maintenance, we have seen that worker nodes and master nodes start to getting some timeouts even when they are talking to etcd proxy, which should forward connections to whatever member it's available. Have you guys seen anything or hear anything like that where etcd proxy is not forwarding necessarily to the right members?
Yeah, maybe there's a bug. The proxy is not super reliable. So for us, we just use SAD client directly. And for some of our deployment, we even have the API server talk to the SAD cluster just locally. So we co-locate the SAD server with the API server. Right. So we haven't tested the proxy extensively. But if you hit a problem, probably create issue on SAD repo, so we can help to look into the problem for you.
Okay, and on the same cluster, sometimes I see a regular warning on etcd saying that it took so long to apply entries or something, optimize your queries or something. But this is Kubernetes talking to it, and I'm not gonna go and modify the queries. So I will say, other than as this message shows up every time the clusters it's getting bigger. So I just throw more resources to etcd to be able to handle this. But is there any other workaround that I should do instead of just throwing more hardware at it?
So the problem is sometimes Kubernetes try to send very large range queries to SAD, getting large number of keys, like thousands of keys, and that query can take a long time to run. So in 3.4, we are working on for a feature called concurrent read. So it will not block. So when you issue a large read to SAD, it will not block other requests. So that message will disappear. But for now, you probably need to throw more resource to SAD to vertically scaling it. This issue also will be mitigated at the Kubernetes side because in Kubernetes we are working on a feature called pagination. So when Kubernetes tries to get a lot of resources, it will get a chunk after another chunk. It will not try to issue a huge run request to SAD to block other requests.
To leave requests.
Yes.
Yeah, with an offset or something. Okay. Okay. Thank you.
I just have a question, like the wall file and the DB, and how do they compare to the snapshot when you're trying to bring a new member up?
The snapshot is a concept from Raft. So once Raft takes a snapshot, the old WAR files can be deleted. So the database file is more about the SAD data store state. So yeah, the concept of snapshot is for Raft. It's some internal Raft stuff.
Is there an index mechanism? You mentioned queries. Sometimes you need to have a set of pods with a certain label. Currently I don't see anything like that.
So for the indexing problem, there are several ways to solve it. So we have been talking about this for quite some time. So first, one way is to add the indexing to Kubernetes API server. So in Kubernetes API server, we index everything, have a B tree or hash table in Kubernetes API server. The second thing, the alternative thing we can do is to make SAD understand protobuf encoding. So when you save stuff to SAD, you register the key space with a protobuf file, and SAD start to decode the protobuf file, and then we can start to build the index internally in SAD. So there are two alternatives, and Joy is working on this, and probably will publish a proposal in SAD repo and to see whether we should do it in Kubernetes or should do it in SAD, but we are solving this problem right now. Yeah, maybe.
Yeah, we're not sure which alternatives are best. There's the two that Xiang mentioned. Also, the idea of maybe having either symlinks or labels on objects might be a lighter way to do this. But we will open an issue on etcd, and anybody that's interested, I hope you jump in, listen in, give us your suggestions.
Thanks. Yeah, can you talk a little bit more about performance considerations of running large Kubernetes clusters on etcd? Are there like any configuration settings or other than like throwing hardware at the problem?
Yeah, I actually have a backup slides talk about why SAD is slow, right? So a lot of people ask me the question like, why SAD is slow? Like for us, we run very large Kubernetes cluster at Alibaba, probably larger than most of the clusters that you guys are running. And we are facing the problem and we are solving it. So the first thing is check your disk I/O. If your disk I/O is slow, SAD will be slow because, as I said, so for each write request, SAD needs to sync down to the disk through the WAR file. If your disk is slow, it will be slow. A fast SSD is good enough. Matter your latency of a write probably should be under 1 millisecond or something for large clusters, and the NVMe is suggested.
Do you have to like tune the timeout in that case?
Yes, you have to tune the timeout.
Okay.
Well, you don't have to, but your throughput will be lower.
Yes.
You can tune it to see whether it helps. But our suggestion is still like choose a faster disk.
Yeah.
So in SAD, some case the disk I/O will block the heartbeat, but mostly it shouldn't.
I see. Okay, so it's not as much as a concern for the heartbeat as like read-write performance.
Yes. Yes.
Yeah. Okay. Thank you.
So the question about whether there's not enough memory begs, what do we expect of memory consumption, or what should we expect?
So SAD requires or like expect you to have a memory size larger than the total number or total size of your key value space, including the old keys. So say your database size is 2 gig, you have to have like say 3 gig of memory, 1 gig more for some like headroom, right? So there is a matrix to show that how much disk space is using by the backend database file. If that shows like 2 gig, you have to have 2 gig memory. So one easy way to measure whether you have enough memory space is to check the read I/O from the SAD process. So we expect to see the read I/O to be very, very low, probably lower than like 10 read I/O per second. If you see that number going up, it means that SAD is swapping out pages from disk to memory, and that hurts the performance of SAD. So in Alibaba, we have seen that, okay, SAD is swapping pages into the memory and spending 4 seconds. SAD will be hanging there for 4 seconds, and everything will crash.
Allow me to rephrase the question. From user perspective, from the developer, what impacts the memory consumption?
So the number of keys you put into SAD.
All keys are in memory?
Yes, all the keys and values will be served in memory. We expect that all the keys and values to be in memory. That's a consumption that we made a while ago.
In case of reads, does the reads happen from the WAL files alone, or does it happen from the DB file as well?
It's from two places. So we have a in-memory cache. It reads from there first if you hit the cache. And there is the database file, which is the on-disk checkpoint. It is mapped. So if you have enough memory, those pages will still in memory, right? And then you read from there. So that's the two places that a read can hit.
And in case of corruption, what are the scenarios when etcd can repair itself in case of data corruptions?
Data corruption?
Yes, like the DB file or the WAL file, if it gets
So
corrupted.
if the WAL file is corrupted, SAD will detect that and then tell that, okay, the WAL file is corrupted because it's all CRC checkpointed, checksummed. For the database file, right now it's not fully checksummed. So there may be a corruption in your database file. But we add another feature called hash. So SAD, when you run SAD, it will keep on hashing the internal state and compare through the cluster. If it detects, okay, there is a value or a member in the cluster have a different cache than the other two members, it will say that, okay, this member is probably corrupted. So replace that with a new member, delete it, add a new one, and then get a snapshot from the other nodes and to recover the state.
I have two questions here.
Hi.
So one is I'm trying to determine that till what granularity etcd write performance is dependent on disk I/O latency. So is it like write request is said to have completed only when we write to memory and later it can f-sync with disk, or write request is only said to have completed when the data has been dumped on the disk?
Can you repeat your question?
Is there a cache? Is there a write cache?
Is there a write?
Yeah.
Okay, so there is a write cache that only helps the throughput. It won't help with the latency, because for latency, from latency point of view, every write has to sync down to disk before returning it. But we have a write cache that's only for throughput, increasing the throughput.
Okay, the request only completes when we get a confirmation from disk.
When the disk returns the write completes to the client.
And second question is is there a upgrade metrics for etcd? In sense that, like, can you upgrade from 3.1 to, like, say, 4.0, or you have to go from 3.1 to 3.2?
You have to go one version after another version.
And that upgrade matrix you have to supply separately during the upgrade process.
Say it again, sorry.
So, for example, if you have a 3-member etcd cluster, and all are on 3.1, so I have to, like, by phase I have to do, like, 3.1 to 3.2 and then 3.2 later on.
Yes.
So that information, where can I find that information? It's there in.
Okay, so SAD use sim version. Maybe you can answer the question.
Yeah, you mean the documentation or?
Yeah, some sort of manifest of upgrade workflow.
Oh yeah. In the documentation, it's very detailed, recorded, and then it have documentation for upgrading from 3.1 to 3.2, and documentation of upgrading from 3.2 to 3.3, and even documentation from how to upgrade from SED2 to SED3. And then if you want to upgrade from 3.1 to 3.4, for instance, then you have to go through like each stage and upgrade the entire cluster to the one minor version upper, and then do it. Yeah.
And there are utilities like etcd ADM and etcd Operator that can help do this for you if you don't want to do it manually.
In a recent PR, 10311, you proposed replacing BoltDB with Badger. Could you just speak to your reasons for this?
Yeah, I think I just mentioned that like for SAD we want to support HDD better, or like to reduce the memory usage, right? So better LSM-based backend will be better fit for that use case. But LLM-based approach will use much more CPU and much more memory for your normal use case. So for small clusters, we'll still suggest BoltDB because it's very lightweight. But for larger deployment, we are experimenting with LSM-based approach. Yeah, it's pluggable backend. Well, you can you can actually bike SAD by say MySQL or whatever. We don't really care, but we're just experimenting with some other alternatives.
I had a quick question about the compaction. And so it sounds like we keep the history of all the keys, which is a cool feature. Do I, as a user, have the ability to prune old keys if I want to?
Yes.
Cool.
Yes.
Yes, and there's a couple ways you can do it. There's some flags that do automatic compaction based on a policy, or if your client knows best, then let it do it. So for example, the Kube API server will do it every 5 minutes on what it thinks reasonable, so you don't have to do anything for that.
Could you talk about incremental backup and or the recommended things to when we are backing up every hour?
Yes. So SAD itself is replicating data to all the nodes, right? So normally you don't need to do the backup. So when you do the backup, probably you do backup for the data, say the data incorrectness. For example, for Kubernetes, when you delete all your ports, right, then you want to recover your state. Probably you want to recover it from a backup, right? So backup is mostly for like saving your application. But for SAD, it's already replicated the data. So if you think that your application is absolutely correct enough, right, you don't need to do the backup. And backup does cost some like IOPS or memory, because when you do it, you need to read the data and send to the other node. So we are adding a new feature called non-voting members. That member will just subscribe to the raft and keep on like getting the new WAR files from the raft and then keep on writing to disk. Then you will have a continuous backup. You don't need to do your backup anymore.
Yeah. So I had a question. So we see in our production that when we have lots of watchers watching a large key, the size of the value is large, and when we update the key, the etcd service needs to send out a lot of bytes during that instant, and then we see some network hiccups and even cause like leader re-election and stuff. Is there any plans to handle that more gracefully?
So I think someone mentioned that we have a thing called SAD proxy. The SAD proxy is supposed to handle this exact use case. So when you have a lot of watchers subscribe on a single key, and the SAD server now needs to find out, that causes a lot of network I/O, right? So we'll have a proxy. So SAD first will find out to a few proxies, and then those proxies will find out to the other clients, and this reduce the pressure on the core SAD members. And this is a proxy. So try the proxy. If you hit an issue, create an SAD like issue in the SAD repo. Will help you to fix them, right? Yeah. So proxy is designed for this, but we don't have enough use case. For example, Kubernetes have 3 clients, right? And it doesn't really work for large. Even if it works for very large values, the value will just send to 3 clients, right?
I have another probably going to be useful slides for you guys. There are some tools that you can use for some of the use cases. Joe and Jingyi had a debugging SCD yesterday. If you look at the video, they have a very detailed introduction on the tools. For example, if SCD cuddle, SCD dump DB is to look what's in the DB file, and SCD dump logs is to see what's in the wall log, and there is Augur. If you're using SCD in Kubernetes, then you can use Augur to decode the protobuf of the Kubernetes object, and you can do some other nice calculations like the value size and how many revisions you have for each key and things like that. I think that answers some of the questions. And you can combine the SCD dump logs and Augur to give you the decoding of the object as well. Yeah.
I think we already ran out of time.
Oh.
So if you have questions, just reach me out. We'll be here maybe for another few minutes. And Joe is here, and Gilho is here. We are all SCD maintainers. Thank you.